Hello all. In this experiment, we are performing regression analysis using Python. So, what is regression? It is a supervised machine learning technique which is used to predict continuous values based on images. Based on the input features we give, we predict what goes on continuous. What continuously goes on is what we are used to predict in regression. So, in this experiment, we will see three types of regression. First, linear regression. Multiple linear regression is the second, and finally, third, logistic regression. And while seeing these regression types, we will also evaluate the models used as SSE, which is the sum of squares error, RMSE, root mean square error, and R square. So first we're going into the linear regression. So first we import the libraries. We generally use the same libraries to export. Pandas is used for data manipulation, NumPy is for numbers and numerical computations, and Matplotlib for visualization. So these help to read the data set, process the data, and plot the graphs. So as usual, we load the data set, and doing any technique, before doing anything on it, we clean the data. We see if any missing values are present, and we replace them with mean imputation. And mean imputation means we're replacing the values with the average value of the column. And after that, we choose independent variable and a dependent variable. Here the independent variable is alcohol x, and dependent variable y is column quality. And we compute regression coefficients. So we get the mean of x, and we get the mean of y, and then we compute b1, which represents the slope of the regression line, and b0 represents the intercept. And we're displaying both mean and the intercept. And then we go on to the regression equation, which is y is equal to b0 plus b1 x, which is the sum of the intercept plus the slope of the regression line into the target variable. So, sorry, independent variable. Into the independent variable, we compute the formula, and then we print the value of the y predicted y value, and then we calculate the sum of squares error, which is the sum of the dependent variable and the predicted variable, the whole square. In short, we can say it as y minus y bar, summation of y minus y bar, the average of the y minus y bar, the whole square. So this measures the difference between actual values and the predicted values. And next we go on to calculating the RMSE, which is the root mean square error. This tells us how far the predictions are from the actual values. So, and it is computed by the square root of sum of squares error divided by the total number of elements. And then we go on to calculate the R square, which is called the coefficient of determination, which is calculated by R square is equal to 1 minus the sum of square error divided by the sum of SST, and this tells us how well the model explains the data. So when R square values became closer to 1, they indicate a better model, and this is a note. And we plotting the regression line next, and we visualizing it. So what we are doing is that we use scatter plot for actual data points and the regression line for predictive values. So see, this regression line is for the predictive values, and these dots and these scatters are for the actual data points. So this helps us understand the relationship between alcohol content and the wine quality. And next, then finally we predict the wine quality for a new alcohol value where I have already entered an alcohol value, and if so, I'll enter it again. Suppose my alcohol value is like say suppose 1.56. It computes and predicts the predicted quality, which is given as 2.913, so on. So this helps predict the wine quality for a new alcohol value. And then we go on to multiple regression, and we take two variables, and as we know that linear multiple regression takes one or more independent variables, and so we took alcohol and sulfates, and we compute the y-intercepts here, regression coefficient using the equation method, and we get the intercept on the alcohol coefficient, and we compute the predicted value of y, and then we calculate the sum of square errors, root mean square error, and the r square value, and we predicting the y also in multiple linear regression. And next we go on is the logistic regression. So it is used for mostly classification problems. Instead of predicting continuous values, it predicts class labels such as 0 or 1. Like if it is a certain type of value, it labels as class 0. It is a negative type of value, some kind of like that. It marks as 1. So again, we pre-process the data and we take independent variables. We take independent variables of fixed acidity, water acidity, citric acid, residual sugar, chlorides, free sulfur dioxide, total sulfur dioxide, and so on. And we take it, and here in the and we take dataset contains a categorical variable called type. Actually, it's this one, the pre-processing part. This is the most important one. As we previously told that instead of predicting those continuous values, we label them as 0 and 1. So here in this wine data set, we classify the type red as 0 and white as 1. And so go on, we're taking the independent variables and dependent variables, and we're using the sigmoid function. It converts values into probabilities between 0 and 1, and then the cost function, which measures the prediction error of the model, and gradient descent to minimize the error, and iteratively update the model parameters to reduce the cost function, and then we training the model, and finally we get the plot where we take iterations was the cost, how many iterations it took, and the cost against that, and then we find the model accuracy, which is we compare predicted values with actual values and compete the percentage of correct predictions. So that's it. And for conclusion, we implemented linear regression, multiple regression, logistic regression. Thank you.